In this problem, we have a 6 feet long uniform thin rod with a weight of 20 pounds, and it's leaning against a 3 foot by 3 foot block. The block itself has negligible weight. So the block is supported at point A by a roller, point B by a pin, and the rod is supported at point C by a pin as well. And we need to solve for the support reactions at all these 3 supports. So if we treat the 2 members as one system and draw our first free body diagram, which is treating them as one system, we will have this block here, and we will have a rod here. Now we will have the force between them. Let's call this point D. The force between them at point D is internal, therefore they do not count on the free body diagram when we are treating both of these 2 as one system. So what forces do we have? We have AY here at the roller support, BX, BY, CX, and CY. And then don't forget we have a 20-pound weight of this rod. So obviously, from this free body diagram, we have 5 unknowns. We cannot solve for all of them. So we need to draw free body diagram of the block and the rod individually. So for the rod, we have CX and CY. So again, let me use red to indicate unknown. We have the 20-pound force. And then at point D, because this is contact support, therefore the force is perpendicular to the rod. Normal to the rod is a normal force, which means that on free body diagram 2, we have a force FD here. We don't know the magnitude yet, but we already know the direction. So this FD force is at a 45-degree angle with the horizon, which means that its line of action is like this. And then we have AY, BX, and BY. So from here, again, from free body diagram number 3, we only have 3 unknowns, and we can solve for all of them. But let's see if we can solve the problem without solving FD. Because remember, we were asked to solve for the support reactions at A, B, and C. So even though we can solve for FD as a sort of like an intermediate step and then substitute it back into free body diagram 2 to solve for the rest of the 3 unknowns, that's doable. But let's just try it to see if we can avoid solving FD in this problem. So if we look at free body diagram number 2, the block is actually a 3-force member. Both of these 2 members are 3-force members, which means that forces are only applied on 3 points. Therefore, we have point A here, point B here, and point D here. For 3-force members, the forces are either concurrent, meaning that they intersect at the same point, or they are parallel. In this case, we already know the direction of AY and FD, and they are not parallel. Therefore, they must be concurrent, which means that we already know that FD and AY intersect at point A. Therefore, force B must intersect with them at point A as well, which means that BY cannot exist. BY has to be 0 because the force at point B must be horizontal. Otherwise, it will not intersect with both AY and FD. So in this case, BY equals to 0. Just make a note here. And we can eliminate that from our first free body diagram as well. So going back to the first free body diagram, if we summarize the moment at point C, Bx, Cx, and Cy, they all have lines of action passing through point C. Therefore, if we summarize the moment about point C, we only have Ay creating clockwise rotation about point C. The moment arm is going to be this distance. If this is 3 feet, this is 3 feet, and this is a 45-degree angle, then this distance must also be 3 feet. So overall, that's 6 feet. And then the weight force is right here. This right here is half of 6 feet, which is also 3 feet. Therefore, the moment arm is 3 feet times cosine 45-degree. And that equals to 0. So from there, we can solve for Ay. Ay equals to 7.07 pound. So that's Ay. From the same free body diagram 1, resultant force along the y direction equals to Ay 7.07 minus 20 plus Cy equals to 0. So from there, we can solve for Cy, which is 20 minus 7.07, so 12.9 pound. We cannot solve for either Bx or Cx, but if we come back to free body diagram number 2, and we summarize the moment about point D, therefore FD does not have moment about point D. We have Ay that's clockwise, so negative Ay times 3 feet plus Bx times 3 feet equals to 0. From here, you can see that Bx and Ay, they equal to each other. So Bx equals to simply Ay, which is 7.07 pound. And lastly, going back to free body diagram 1, you can see that Bx plus Cx equals to 0. Therefore, Cx equals to negative Bx, which is negative 7.07 pound. And we have solved for all the support reactions without solving for the force Fd.